Welcome to Vinod Chemistry classes. In this video, I am going to discuss about intermediate first year topic, states of matter. In the states of matter, I am going to discuss about distribution of molecular speeds and RMS velocity, root mean square velocity or root mean square speed. In my previous video, that is in part 7 of states of matter, I have discussed about how molecular speeds are distributed by using Boltzmann and Maxwell distribution curves. In that, I have used two words. One is average speed and another is most probable speed. One is average speed, another is most probable speed. మనకి పార్ట్ 7 ఆఫ్ దిస్ స్టేట్స్ ఆఫ్ మ్యాటర్ లో డిస్కస్ చేయటం జరిగింది. ఈ మాలిక్యూల్స్ అనేవి ర్యాండమ్ గా ఇన్ ఆల్ డైరెక్షన్స్ మాలిక్యూల్స్ అనేవి ర్యాండమ్ గా ఇన్ ఆల్ డైరెక్షన్స్ ఓరియంట్ అవుతుంటాయి. కాబట్టి వీటిని చెప్పడానికి మనం ఏం వాడుతున్నామని చెప్పేవాడి ఇక్కడ యావరేజ్ వెలాసిటీ లేదా యావరేజ్ స్పీడ్ అన్న పదం వాడింది. సో ఇక్కడ యావరేజ్ స్పీడ్ అంటే కనుకండి, ఇఫ్ దేర్ ఆర్ n మాలిక్యూల్స్ ఉంటే కనుక n మాలిక్యూల్స్ ఉంటే మాలిక్యూల్ 1 యొక్క వెలాసిటీ u1, మాలిక్యూల్ 2 యొక్క వెలాసిటీ u2, మాలిక్యూల్ 3 యొక్క వెలాసిటీ u3, అలాగే మాలిక్యూల్ 4 యొక్క వెలాసిటీ u4 అండ్ nth మాలిక్యూల్ యొక్క వెలాసిటీ un అనుకుంటే కనుక మనకి యావరేజ్ స్పీడ్ ఆర్ యావరేజ్ velocity, average speed is given by sum of the speeds of the n molecules by total number of molecules. This one we are calling it as the average speed of molecules. Average speed of molecules. Similarly, we have seen this molecular velocities mainly depends on two factors. One is temperature and another one is molar mass. Another one is molar mass. So with the second word, that is most probable velocity. Most probable velocity. So the maximum number of the energy, the speed possessed by the maximum number of molecules, we are calling it as the most probable velocity. Most probable velocity. Average velocity is the sum of the sum of the velocities of all the molecules by total number of molecules. That gives the average velocity. And most probable velocity is the the speed possessed by the maximum number of molecules. We are calling it as the most probable velocity. Then third velocity is root mean square velocity. Root mean square velocity. So this simply we call it as a RMS speed. We call it as a RMS speed. So what is RMS speed? RMS speed is the root RMS speed or root square mean square velocity is the mean square speed. Mean square speed is the RMS velocity means the square root of the mean of the squares of speeds of gas molecules. Right? What is RMS velocity? The square root of the mean of the square of the speeds of gas molecules is called root mean square speed. Root mean square speed. What is root mean square speed or root mean square velocity? The square root of the mean of the squares of speeds of gas molecules is called RMS speed. So let a gas consists of n molecules. A gas consists of n molecules. Then the velocity of molecule 1 is u1. Velocity of molecule 2 is u2. Velocity of molecule 3 is u3. And so on. Velocity of molecule n is p1. Then you see square of the speeds. What is what? u1 square, u2 square, u3 square, and so on, un square. You see the mean of the squares. So u1 square plus u2 square plus un square and so on plus un square. Mean means what we have to do? By n. Then square root of. So this one we are calling it as the RMS velocity, the RMS speed. Root means square speed is given by the square root of the mean of the square of the speeds of gas molecules. Mean of the square root of the mean of the squares of the speeds of gas molecules is given by RMS velocity. So here we have seen three kinds of speeds. One is average speed. So average speed is given by U average is equal to U1 plus U2 plus U3, U1 plus U2 plus U3, and so on, UN by N. This is called average speed. Then next one is most probable speed. This one we are calling it as a most probable UMP. Most probable speed we are denoting with the UMP. This is what we are defining is the speed possessed by the maximum number of molecules. The speed possessed by maximum number of molecules. That one we are calling it as the most probable velocity. Most probable velocity. Third one is RMS speed. So this is given by square root of the mean of the squares of velocities by n. This one we are calling it as the RMS velocity. So here we have discussed about three kinds of velocities: average velocity, most probable velocity, and RMS velocity. So we have seen three kinds of velocities. One is average velocity, most probable velocity, and RMS velocity. Most average velocity, average speed, most probable speed, and RMS speed. So these three velocities, these three speeds are most probable speed. So RMS speed, average speed, and most probable speed have the following order. So U RMS is greater than U average and U most probable velocity. Most probable velocity. So this is regarding velocities. So we know that the kinetic gas equation is PV is equal to 1 by 3 mn U square. PV is equal to 1 by 3 mn U square. So if we substitute this and if we have calculated, what we found is RMS speed is given by U RMS is given by 3RT by M. 3RT by M. Similarly, U average, that is average speed is given by 8RT by pi. 8RT by pi. And U most probable is given by 2RT by. Most probable is given by 2RT by M. So most probable is given by 2RT by M, and average is given by square root of 8RT by pi M, and RMS is given by 3RT by M. So here, how these formulas were derived? ఎలా వచ్చినాయి అంటే కనుకండి మనకి కెనెటిక్ గ్యాస్ ఈక్వేషన్ లో ఉన్నటువంటి PV is equal to 1 by 3 mn U square. ఇక్కడ U అంటేనే RMS స్పీడ్ అండి. సో రైట్, అక్కడ ఆ ఈక్వేషన్ లో మనం సబ్స్టిట్యూట్ చేసేవన్నీ డెరైవ్ చేస్తే కనుకండి URMS is equal to 3RT by square root of 3RT by M. సో మనకి ఈ రేషియో కనుక అబ్జర్వ్ చేస్తే కనుక, అంటే ఈ మూడింటికి రేషియో కనుక, అంటే RMS స్పీడ్ కి యావరేజ్ స్పీడ్ కి మోస్ట్ ప్రాబబుల్ స్పీడ్ కి కనుక రేషియో కనుక అబ్జర్వ్ చేస్తే కనుకండి, సో U most probable is to U average is to U RMS. సో ఫార్ములాస్ ఏం చెప్పాము మనం ఇక్కడ? సో 2RT by M, అదే 8RT by pi M, అండ్ ఈస్ టు 3RT by M. 3RT by M. ఇప్పుడు ఒక్కసారి రేషియోస్ కనుక చూస్తే కనుక √2 is to √8 by pi is to √3. సో మనం కనుక దీన్ని సింప్లిఫై చేస్తే కనుకండి 1.00 is to 1.128 is to 1.224. 1.224. Here in these formulas, R is called gas constant. R is called gas constant, and T is the absolute temperature. T is the absolute temperature. M is the molar mass of the gas. Molar mass of the gas. Here R is the gas constant, T is the absolute temperature, and M is the molar mass. So the ratio between these most probable average and RMS speed is 1 is to 1.128 is to 1.224. 1.224. So this is regarding velocities. Distribution of molecular speeds. So molecular speeds are expressed in three ways. One is RMS speed, average speed, and most probable speed. సో ఇక మనకి ఐపీఈ పాయింట్ లో తీసుకుంటే కనుక ఇక్కడ మెయిన్ గా మనం గుర్తుపెట్టుకోవాల్సింది ఈ ఫార్ములా ఏంటంటే ఆర్ఎంఎస్ స్పీడ్ ఈస్ గివెన్ బై డెఫినేషన్ అండ్ ఫార్ములా. సో ఆర్ఎంఎస్ స్పీడ్ ఈస్ గివెన్ బై ఎలా చెప్తున్నాం స్క్వేర్ రూట్ ఆఫ్ 3RT by R, రైట్. అదే యావరేజ్ స్పీడ్ ఏమని చెప్పామండి, స్క్వేర్ రూట్ ఆఫ్ 8RT by 5R. అదే మోస్ట్ ప్రాబబుల్ స్పీడ్ ఈస్ గివెన్ బై 2RT by 5R. ఇక్కడ ఆర్ అంటే కనుకండి గ్యాస్ కాన్స్టెంట్, రైట్, అండ్ టీ అంటే కనుకండి అబ్సల్యూట్ టెంపరేచర్ అంటే టెంపరేచర్ ఇన్ కెల్విన్, అండ్ ఎం ఇస్ ద molar mass. M is the molar mass of the gas. M is the molar mass of the gas. So these are regarding molecular speeds of distribution of molecular speeds. Thank you for watching Trinath chemistry classes. Please like the video, share and subscribe the channel.